everybody and welcome to another 5-minute masterclass. Today's topic is the basics of circle theorems. Now there are lots of different circle theorems, so there's 7 here on the screen that you can see that we do need to be able to learn before our GCSE exam. Well, for today we're going to just concentrate on 4 of them. So I'm going to walk you through angles in the same segment, angles in a semicircle, angles at the centre, and cyclic quadrilateral. Okay, so we've got 4 different examples to work through. So here, I want to calculate the size of angle DAB. So DAB means we're looking to calculate theta. Notice what we've got here. We've got 2 points on the circumference that are meeting in the centre, but then also join up at the circumference as well. So what this is lending to is the angle at the centre theorem. And angle at the centre, that theorem tells us that this angle at the centre here is 150 degrees. It's twice the amount at the circumference. The angle at the centre is 2 lots of the circumference. So writing that down, I've got DCB is going to be 2 lots of angle DAB. Okay, so let's fill in what we know. We know angle DCB is 150 degrees, and we know it's 2 lots of angle DAB, which in this case has been called theta. So to remove this multiplied by 2, we're going to do the opposite, the inverse, and we're going to divide both of them by 2. And it's going to give me an answer of 75 degrees. And we have solved or calculated the angle. Okay, so on to example 2. So here I've got 2 points on the circumference that are meeting up or joining up, meeting with 2 different line segments in 2 places. So I'm using the same 2 points and they can create a segment here and they're joining up at the end. So what we've got here is angles in the same segment. Okay. Now what that theorem does, the angles in the same segment, is say if we join these 2 corners up, so I'll show you in one colour. So these 2 here where they meet, so from D and C they both meet at A. But D and C also, if I join these 2 up, also meet at the circumference at B. And what follows then with that theorem is saying, well, those 2 angles must be the same. So DAC is the same as DBC. And we can fill that in then. DAC, we've been told, is theta. DBC equals 47 degrees. So therefore, DAC, that theta, is 47 degrees. Example 3. Thinking about what we've got here, I've got 2 points that join through the centre and back out the other side. So what we've got is a diameter. And that diameter creates 2 halves of a circle. It creates 2 semicircles. So we're going to use the theorem angles in a semicircle. Now, what tells us that angles at a semicircle, wherever they meet at these on the circumference, so wherever C is, it doesn't matter where it is on the circumference, it will always generate a right angle. So C could be down here, it could be over here, or up here, it doesn't matter. It will always create a right angle. And so then what we end up with is a right angle triangle within this circle for us to be able to support calculating what theta is. Now we know from our prior learning that angles in a triangle add up to 180 degrees. So that means then that theta plus 67 plus that 90 degrees equals 180. So to work out what theta is, we can just take these away. 180, take away 90, take away 67, gives me that missing angle, a value of 23 degrees. So BAC, angle theta, 23 degrees. Final example for me to show you. This time we've got 4 points all on the circumference. And so what we end up here is with a quadrilateral within this circle. So a quadrilateral within a circle where all 4 points are coming at the end, coming toward that circumference, gives us a cyclic quadrilateral. Now the theorem for the cyclic quadrilaterals tells us that opposite angles within a cyclic quadrilateral add up to 180 degrees, sum to 180 degrees. What that means then, if we write it down, is that DAB plus DCB equals 180 degrees. I'm going to sub my numbers in. Angle DAB is 51. DCB we don't know, so it's theta, equals 180 degrees because our theorem says so. To calculate theta then, we just need to take away 51 degrees to find the difference, which gives us an answer of 129 degrees. And we're done. Okay, so a whistle-stop tour of those 4 different theorems, and now it's over to you. Pause the video, try these questions. When you're ready, press play. Here are your solutions, so mark your work. And if you need any more practice, log on to Sparks, Corbett Maths or Maths Genie for further videos and questions to support your learning. Thank you for taking part today, and I'll see you again for another 5-minute masterclass.